This suggests that information in the universe is fundamentally bounded by area, not volume. The holographic principle takes this further, proposing that the maximum information content of any region of space is proportional to the area of its boundary. If the universe has a cosmological horizon, as ours does due to dark energy and accelerating expansion, then the total information content of our observable universe is finite. It's proportional to the area of the cosmological horizon. This means the universe is a finite quantum system. The Hilbert space is enormous, but finite. The quantum state is a specific vector in this finite dimensional Hilbert space. The universe is quantum information, and the amount of that information is finite and bounded. Now, here's where it gets really interesting. If the universe is holographic, if the holographic principle applies to the whole universe as it does to black holes, then all the information about our three-dimensional universe is encoded on the two-dimensional cosmological horizon. The three-dimensional space we experience, with all its galaxies and stars and planets, is a holographic projection from information on that distant two-dimensional surface. We're living in a hologram. The universe is really two-dimensional information on the boundary, and the three-dimensional reality we experience emerges from that information. This is what the ADIS CFT correspondence teaches us. It's a concrete, mathematically precise realization of this idea. In AD-CFT, the boundary theory is fundamental. It's a quantum field theory with no gravity, no extra dimensions, just quantum fields on a lower dimensional space. And from the quantum state of that boundary theory, an entire higher dimensional space-time emerges. Black holes, gravitational waves, the expansion of space, all of the phenomena of general relativity emerge from the quantum information on the boundary. The universe is the boundary theory. The bulk space-time is a derived description, an emergent hologram. If this applies to our universe, and I think it does, then the universe is fundamentally a quantum theory on the cosmological horizon. Everything we experience, all of three-dimensional space, all of time, all of physics, emerges from that two-dimensional quantum theory. The universe is quantum information on the surface, and we're patterns in that information. Let me tell you what this means for the fundamental laws of physics. If the universe is quantum information, then the fundamental laws are laws about information. They're laws about how quantum states evolve, how information is processed, how entanglement grows. The laws of physics we know, Einstein's equations for gravity, Maxwell's equations for electromagnetism, the standard model of particle physics, all of these are emergent laws. They describe the behavior of the universe at the level of the emergent space-time and matter description. But at the fundamental level, the laws are simpler. They're quantum mechanical laws governing the evolution of the quantum state on the boundary. And add CFT, these are the laws of conformal field theory. In our universe, we don't know exactly what they are yet, but they're probably similar. The fundamental laws are about quantum information, and everything else emerges from them. This is a profound simplification. Instead of having many different laws for different forces, different fields, different aspects of reality, we have one fundamental law governing quantum information. Everything else is derived, emergent, a consequence of that fundamental law. This is what physicists dream of. A unified theory, a theory of everything, not in the sense of a theory that describes all the particles and forces, but a theory that shows how all of physics emerges from one fundamental principle. And that principle is quantum mechanics applied to information. Now, let me address what I think is the deepest question. What is this quantum state? Why is the universe in this particular quantum state and not some other state? This is where we reach the limits of current knowledge. We don't know why the universe is in the particular quantum state it's in. We can describe the state, we can study its properties, we can derive emergent physics from it. But we can't yet explain why this state rather than another. Some people invoke the anthropic principle. The universe is in a state compatible with our existence because if it weren't, we wouldn't be here to ask the question. This is true but unsatisfying. It doesn't explain why this state exists, just why we observe it. Others propose a multiverse, an ensemble of universes in different quantum states, and we happen to be in one compatible with life. This pushes the question back. Why does the multiverse exist? What determines the probability distribution over states?
What we're looking for is how everything works, what makes everything work. The truth is so remarkable, so amazing. I and many other people who have studied far enough to begin to understand a little of how things work are fascinated by it. It's curiosity as to where we are and what we are.
Algebra is like sheet music. The important thing isn't can you read music, it's can you hear it. Can you hear the music, Robert? Yes, I can.